So this is the last section we're going to do in chapter 6. It's 6.5. First thing we have to do when we are solving equations with radicals, so equations like down here, they'll have an equal sign, is isolate the radical. The radical has to be the only thing on that side. The second thing we have to do is raise both sides of the equation to the power, or the exponent, that's the same as the index. We do this because it cancels the radical. So this one here, if you look, the index is here. Remember, we always look, that's where the index is, and we circle it. This index is not written, so we know the index is 2. So since the index is 2, we raise both sides to the second. That will cancel the radical, and it will give us x plus 7. Here, the index is 3, because there's a 3 written in the index spot. So we raise both sides to the third, and then it cancels the radical, so it's x plus 7. However, something you need to make very sure that you know is when there's not a radical and you have something like x plus 2 and you square it, that really means if you're squaring something without a radical, it means there's 2 of them. And if you had something like x plus 2 and you squared it, you would have to FOIL that, okay, or multiply those binomials. So you would have to multiply all of those and you would get a lot more stuff. So I don't think I gave you any like that, but if I did, let me know and I'll help you with them. Once you have done that, we will solve the resulting equation. So once the equation, after the radical is gone, you solve what's left. So if it's just linear, that means it has no x squared term, and all you need to do is get the x by itself. If it's quadratic and has an x squared in it, you would have to do the quadratic formula. And if that comes up, check back in your 4-7 notes. That's where that is. So if you raise both sides to an even exponent, so remember even exponents are like 2, 4, 6. If that happens, you must check for extraneous or false solutions. You do this by substituting all the answers back into the original equation, then work each side of the equal sign separately using PEMDAS, because raising stuff to powers can sometimes give us a false solution. So we have to do this. So first thing, we're going to try this one. First step said to isolate the radical. So looking on the radical, looking on the side of the equal sign where there's a radical, do you see anything that's not under the radical? So this is isolated. That is done. I did want to change this to a plus. Okay. That is isolated. So since it's isolated, then I look in my index. There's no number there, so that tells me it's a 2. So I raise both sides to the second power. Once that happens, the radical on this side and the squared cancel each other out. So that's just a 3x plus 1. This side I have 5 squared. Well, 5 times 5 is 25. And now all I need to do is solve the equation. So to get the x by itself. So I subtract 1, 3x equals 24, divide by 3, x equals 8, I think. But I'm not done. Do you see this 2? Is 2 an even number? That is. It's an even exponent. So what that means is I have to check my answer. So how we do that is we write the exact same thing that the original problem said. So square root of 3, but instead of putting the x, we put the number we got as an answer. 3 times 8 plus 1 equals 5. Now we do each side of this separately. So I'm going to put a pin in my way. So I ignore that side of the equal sign and I just work on this side. So 3 times 8 is 24. 24 plus 1. 24 plus 1 is 25. The square root of 25 is 5. Well, this side doesn't have anything to do. So it's just 5 all the way down. So does 5 equal 5? Yep, that checks. So I know 8 is my answer, and that's what I'm going to put into Math Excel. 8 is my answer. This is just like if you had a research paper, this would be like your citing. This would be what you cite. This is your proof that 8 is the answer. Okay, next one. First thing I have to do is isolate. On this, so looking at the radical side of the equation, I see a 9 there. I can't have that 9 there. So subtract 9 from both sides. So then I have square root of 1 minus 35x equals 6. After I isolate, then I need to raise both sides to the power of the index. So my index is right there. When there's no number written there, it's a 2. So I'm going to square both sides. So the radical and this squared, since the index is a 2, this cancels. So it's 1 minus 35x equals 6 squared, which is 36. And now that I have everything, all the radicals are gone, I solve for x. 36 minus 1 is 35. Divide both sides by negative 35. So I think x equals negative 1. Am I sure? No, because this is an even exponent. I have to check. So same thing. Original problem, 9 plus square root of 1 minus 35 times x, which is negative 1. To make sure that goes underneath my radical. That equals 15. So now we learned from the last one that if there's nothing to do, like the 15 side, there's no math to do over there, so we could just bring it down. This side, though, we need to do some math. So 9 plus, we work underneath the radical first. 1 minus 35 times negative 1. Well, 35 times negative 1 is multiplication, so that has to happen first. So negative 35 times negative 1 is positive 35. So this is 35 plus 1, which is 36. The square root of 36 is 6. 9 plus 6 is 15. So 15 does equal 15. Checked it, it's right. So here's my answer. That's my proof. Next one has a little bit more going on. We have a lot more over on this side to isolate. So when we isolate this radical, we have it multiplied by 5 and we had 7 added to it. So by PEMDAS, we're going to do PEMDAS backwards. So we always undo any addition and subtraction first. So do we have addition and subtraction? Yep, we have a 7. So we're going to subtract 7 from both sides. So I have 5 times the square root of x equals 1. Now I have to undo this multiplication. So the opposite of multiplication is division. I'm going to divide both sides by 5. So square root of x equals 1 over 5, or 1/5. Now that my radical is isolated, I need to look at the index. Once again, there's no number there. So hopefully we're really good at remembering when there's no number there, it's a 2. So raise both sides to the second power. That cancels the radical, so this side is just x. This side we square both of the numbers. So 1 squared, 1 times 1 is 1. 5 squared, or 5 times 5, is 25. So is that the correct answer? I don't know, because this was even, so I have to check it. So 5 times the square root of 1/25 plus 7 equals 8. Okay, so let's put that in there, 1/25. Okay, so to do this, the square root of 1/25, I do the square root of 1, which is 1, and the square root of 25, which is 5. Okay, now 5 and 1/5 are inverses. When I have inverses and I'm multiplying them together, the answer is 1. So this says 1 plus 7 equals 8. Well, does 1 plus 7 equal 8? Yes, it does. So this is my answer. That's my proof. Last one. Do we have anything we need to move from the radical side? Do we need to isolate it? Nope. It's already isolated, so that's done. So now we look at the index. What's our index? My index is 3. So both sides get raised to the third power. And this is different. We haven't done that yet. So the radical, the index of 3 and the power of 3 cancel the radical. So this just says x plus 1. Now this side says 2 to the third. What that means is 2 times 2 times 2. So that gives me 8. Then the last thing we do after the radical has been canceled is solve for x. So x equals 7. Now, do we need to check this one? Well, we look at the power. This is an odd power or exponent. So we don't need to check it. Those false solutions are only given when we have even indexes. Okay, good luck on your Math Excel. Let me know if you have any questions.